Hi everyone. So today we are going to discuss about a small topic, yet an important one, which is a plateau potential and the pacemaker potential. So there are two types of cells or tissues in the heart. One is a normal myocardium, which is present in the atria and the ventricles, and which will contract and relax during the cardiac cycle for the pumping of the blood. So the action potential which is developed in them, that is called the plateau potential. Okay, and in the there's another type of tissues, that is a specialized nodal tissues which are present in the conducting system of the heart, that is in the SA node, AV node, in the Purkinje fibers and bundle of this and all. So the type of action potential that develops in them is the pre-potential or the pacemaker potential. Okay, so first let's discuss about the plateau potential which develops in the main myocardium of the heart. So as you can see, this is the diagram of it. So from this, when you look at this diagram itself, it appears like a plateau. It has a very stable face. One of its face is very stable and straight lined, so that is why it's called a plateau potential. Okay, so now let's come to the different phases of the plateau potential. Okay, so the first thing that we have to remember here is the resting membrane potential. So the resting membrane potential for the normal myocardium, it is minus 90 millivolts. It is minus 90 millivolts for the myocardium. Okay, now what happens in action potential? You will be having two phases for everything, whether it is nerve or muscle. You will be having a depolarization or a repolarization, right? So during first what has to happen? The depolarization has to happen. So during depolarization, the potential inside the cell has to increase. So from minus 90, the potential increases till it will overshoot the plus 0, and it overshoots 0 and will reach somewhere near plus 20. Okay, now so what is the reason? The potential is going from negative to positive, so there is an influx of positive ions into the cell. Okay, so which is a positive one entering is the sodium. Okay, so as in nerve also it is sodium, here also it is sodium influx that is leading into the depolarization. Okay, now the depolarization is represented by the phase 0, okay, of this graph. Now coming to the next phase, that is 1. So 1 represents the first rapid repolarization. Okay, so 1, 2, 3 are all of them are repolarization, because we can see the potential is coming down back from the positive to negative. It is the muscle cell is getting repolarized. Okay, but in 1 it is a steep line, so it is a rapid repolarization. So phase 1, it is a first rapid repolarization. So what is the reason for a rapid repolarization? The influx of sodium ions which was occurring in phase 0 has to stop. That is the first thing. So the Na plus channels has to close, and then what has to happen? Repolarization. Normally what happens? K plus efflux happens, right? Then only the membrane and the potential inside the membrane will convert from positive to negative. So positive ion should go out, so it's K plus efflux. Okay, so for that the K plus channels will open. Okay, so K plus channels opens and Na plus channels close. That is what happened in the phase 1. Okay, now there are two types of K plus channels. Okay, there are so this is I have written the points here. Depolarization means negative to positive plus 20 to reach plus 20, that is because of opening of Na plus channels and influx of Na plus. Then the phase 1 means it is rapid repolarization. Here the closing of Na plus channels and opening of K plus channels. Now we have important point is that K plus, there are two types of K plus channels. Okay, there is a slow or IKS, it means ionic potassium channel, which is slow. Okay, and then there is an ionic potassium channel which is rapid. So in this rapid repolarization phase, it is the rapid channel that is getting opened, and it is to that the K plus is effluxing. Okay, now next is the phase 2. So the phase 2, you can see the potential, it barely changes. There is no much change. It's more like a straight line. So there is an influx and efflux of a positive ion. So the potential got, and they got balanced one another. Okay, positive ion is going inside and a positive ion is going outside. So likewise, like that, it got balanced. So which was a positive ion which got outside? K plus is already going out, so that's a positive ion which is going inside, outside. Now what should come inside? One has to come, that is calcium. Okay, So calcium will come inside to the cell, so that will be counterbalancing the potassium which is going out to the cell, and so the potential will remain constant. Okay, now this calcium is also having two types of channels. It has like similar to that of potassium, it also has a slow or a delayed channel, and a rapid or a fast short lasting channel. Okay, so this phase you can see it's a delayed phase, it's a plateau phase. Okay, so it is there for some time, it is prevailing there for some time. So which type of channel has to be opened during this phase? It is the slow or the long lasting calcium channels which is active, and it is through these channels that the calcium is influxing, okay, and balancing the K plus efflux, so that the potential has more or less the same. So now there will be a doubt whether that is calcium is a divalent ion and potassium is a monovalent ion, but the number of this is not mentioned, right? So the number can change, that is more amount of potassium will be effluxing more number wise, so they can get balanced. Okay, now next phase is phase 3, that is the next final repolarization or late repolarization. That in that phase we can say again like the phase 1, the potassium is effluxing but there is no calcium. So if calcium was there, it would also have been a straight line. It's not straight, it's a steep line, right? So the calcium channels is slow or long lasting calcium channels has closed, and the only ionic movement taking place is K plus efflux, and K plus efflux is taking place through, in this phase it is taking place through both the channels, both the slow as well as the long lasting potassium channels is working over this in this phase. Okay, now okay, so that is what I have written over here. Both the rapid as well as slow is functioning. Now the phase 4. So the phase 4, it is a phase, it is not a repolarization, it's not a part of repolarization. After the phase 3 itself, the membrane potential has reached the plus 90 and minus 90, which is the rest membrane potential. But the thing is that what is the difference from compared to the initial configuration of that membrane and now? Initially more sodium outside the membrane and more potassium inside the membrane. Okay, but now it has the same potential, that is minus 90 millivolt, but the concentrations of sodium and potassium are just the reverse of the initial condition. Now here what had happened, the potassium is more outside and sodium is more inside, so that has to be reversed. So with the help of the ATPase, the sodium potassium ATPase, Na plus K plus ATPase, which will be pumping out 3 Na plus out of the cell for 2 K plus into the cell, as we have learned it already in nerve and everywhere. So with the help of this concentration difference will get balanced, and the cell will become just the same as its initial starting state. Okay, that's the thing. Now that's another term called the absolute refractory period. So it's a period during which the myocardium does not respond, or any cell. It is not only defined for a myocardium, it is just, defined for a nerve also. It is a period during which that nerve or that muscle or that excitable tissue does not respond to a second stimulus. Okay, so in the case of this myocardium, the depolarization, complete depolarization, and if 1/3 of repolarization comes under the absolute refractory period. That means in the graph the phases 0, 1, 2 and early half of 3 comes under absolute refractory period. So that is a big phase, right? It's a long phase. So the cardiac muscle, this has a very important clinical aspect, an advantage, that is the cardiac muscle will not get tetanized. So what is tetany? Tetany means smooth sustained contractions, right? So during the smooth sustained contractions means the stimulus for the second contraction should come during the contraction phase of the first stimulus, right? Then only it can happen smooth sustained contractions. But here in the case of cardiac muscle, as the absolute refractory period is long, and any stimulus which is coming during that period will not produce an response, or will not produce, or will not result in the contraction of the myocardium. So This tetany condition cannot occur in cardiac muscle. So cardiac muscle cannot be tetanized because its absolute refractory period is quite long. So that is about it's all about the plateau potential. Now about the pre-potential or the pacemaker potential, we'll do it as the next video. Okay, thank you.